with the first numerical. A T section with flange 120 mm into 10 mm and width 10 mm into 120 mm is used as a simply supported beam with flange at top. If the permissible bending stress in tension and compression are 160 megapascal and 100 megapascal respectively, determine the moment of resistance. अब यहाँ पर हमें MR find करना पड़ेगा. So the diagram of the T section is drawn there, and let us get started with this numerical.
So for this question, a T section is given as shown in the figure here, and for this T section it is simply supported at this flange, top flange here. So and from the given, let us just write down what are given from the question. We have permissible bending stress in tension and compression are, so permissible bending stress compression, and in tension we have 160 megapascal MPa. This is given. Next, what is given? And 100 megapascal. So from here what we can say, sigma C is equals to 160 megapascal, sigma T is equals to 100 megapascal. Okay, and we need to determine the moment of resistance. So moment of resistance is signified by MR, so we need to determine this one. Okay, so for this T section, let us say how we can determine MR. Now from the flexural formula, MR by M by I equals to sigma by Y. From this flexural formula we can find the value of MR here. Okay, now what do we need? Sigma is given, Y we need to find, I we need to find. To find Y for this T section, Y bar will be equal to YT, which will be equal to A1 Y1 plus A2 Y2 divided by A1 plus A2. Now from here, A1 section, this is section 1 and this is section 2, right? Okay, so from here area 1 for this section 1 will be equal to 120 into 10 into Y1 will be equal to 120 divided by 2, which is 60, plus area 2 120 into 10 for this second section here, which is flange portion. So 120 into 10 into what will be Y2, we need to find it. यहाँ तक फाइंड करना है, तो कहाँ से आना है? बॉटम से ये पॉइंट तक जाना है, तो कैसे जाएंगे? From here to here it is 120, so I have 120 plus, now I need to go half of this. फ्लेंज का डेप्थ कितना है? 10, so 10 divided by 2, 5 it will be, so I'll get 125 divided by total area 120 into 10, which is area 1, area 2 is again 120 into 10, right? So from here you will get YT equals to 92.5 mm. Okay, and अब YT यहाँ से यहाँ तक का डिस्टेंस इज YT आपको मिल रहा है 92.5 mm. Okay, so from here, by using we can just use this formula to find moment of resistance MR. So how we can do this? If we modify this formula as MR divided by I equals to sigma C by Y, sigma T by YT. हम ऐसे फाइंड कर सकते हैं, because we know the value of sigma T 100 megapascal, we know the value of YT, which is equals to 92.5 mm, or else we can either use MR by I equals to sigma C by YC. We can also use this formula. Now if we use this formula, sigma C here will be equal to sigma c will be equal to total depth. What is the total depth? 130 minus 92.5. This will come equal to 37.5 mm. Okay. And now we have to find I. How will we find I? To find I, we need to use a parallel axis theorem. So parallel axis theorem for this section 1 will be equal to BD cubed by 12 plus A1 H1 square. Section 1. For section 2 it will be BD cubed by 12 plus A2 H2 square. This will be for section 2. Now for section 1 B kitna hai? 10. D is 120. So I have 10 into 120 cubed by 12 plus area will be 120 into 10. Now H1 will be equal to YT, which is 92.5 minus, अब ये सेक्शन का डेप्थ 120 है तो 120 डिवाइडेड बाय 2 इज 60 स्क्वायर. सो ये हुआ आपका फॉर फर्स्ट सेक्शन, राइट? मोमेंट ऑफ इनर्शिया फॉर दिस फर्स्ट सेक्शन प्लस मोमेंट ऑफ इनर्शिया फॉर द सेकेंड सेक्शन इज ये सेक्शन फ्लेंज पोर्शन के लिए B is 120, D is 10. So 120 into 10 cubed by 12 plus area will be 120 into 10. Now अब ये पोर्शन हमें पता है which is YC. YC कितना आया है? 37.5, राइट? अब यहाँ से हम सिर्फ ये न्यूट्रल एक्सिस के ऊपर के पोर्शन लेते हैं तो 37.5 माइनस इतना लेना पड़ेगा, इसका आधा, फ्लेंज का आधा, which is 10 by 5, 10 by 2 which will come 5. So I have 37.5 minus 5. ये 5 कैसे मिला? ये फ्लेंज का जो 10 mm थिकनेस है 10 by 2 किया तो हमें सिर्फ इतना डिस्टेंस चाहिए. So इतना डिस्टेंस कितना होगा? 10 divided by 2 which is 5 the whole square. Okay. अब यहाँ से moment will come equal to 39.8 into 10 raised to power 5 mm raised to power 4. ये आपका IXX. Now let us find MR. हम ये यूज़ कर सकते हैं. So इस पे यूज़ किया तो MR will remain as it is. MR will be equal to sigma C by YC into I. Now from here sigma C कितना मिला? 37.5 divided by YC. Oh, I'm sorry, this is not sigma C, this is YC. Okay, so yeah, this is not 37.5. YC is 160 MPa. So 160 megapascal is Newton per mm square divided by YC is 37.5 into moment of inertia 39.8 into 10 raised to power 5. So from here you get MR equal to 68.9 into 10 raised to power 5 Newton dot mm. So this will be the resistance. Okay, so I hope this numerical is clear. Let us solve the second numerical.
A cantilever beam of solid circular cross section and 3 meter long carries a concentrated load of 35 kilonewton at its free end. If the maximum bending stress in tension or compression is not to exceed 125 Newton per mm square, determine the diameter of the beam. So let us see how we can solve this numerical.
Now let us solve the second numerical. For this second numerical, a cantilever beam is given. Okay, so cantilever beam, is given. Okay, and the length of this cantilever beam is equal to 3 meters, and it has a point load acting at a free end 35 kilonewton point load. Okay, and now from the question again a stress is given, right? So stress is given in tension and compression. Stress sigma is given, compression and in tension it is given equal to 125 Newton per mm square. This much is given, right? Now it is saying that it is a cantilever beam of solid circular section. It is a solid circular section. So it is a solid circular section, right? And its neutral axis will pass right from in between, right? Up we need to find, for this we need to find the diameter of this beam. We need to find diameter d equals to question mark. Now let's see how we can find, again by using the flexural formula, which is m by I equals to sigma by y. Let us find diameter d. Now for this cantilever beam, maximum moment for this cantilever beam with a point load at its free end will be equal to W into L. If I name this as A point and B point, maximum moment will come at A point, which is fixed end point. So here I have 35 into length of the beam is 3, right? So I will be getting equal to 105 kilonewton meter. Now I want to convert this kilonewton to newton and meter to mm. So if I convert it, I'll be getting equal to 105 into 10 raised to power 6 newton dot mm. Okay, now let us find moment of inertia, Ixx, for a solid circular section is equal to pi by 64 d raised to power 4. Now we do not know d, तो हम इसको ऐसे ही छोड़ देंगे. Okay, we will leave it as it is and let us find y. Y will be equal to d by 2. Again, we do not know the value of d. Now let us put all this value in this formula and find m. We got 105 into 10 raised to power 6. I is pi by 64 d raised to power 4 equal to sigma is 125 divided by y is d by 2. So this is what we are getting, right? Up now if I cross multiply it, I'll be getting 105 into 10 raised to power 6 into d by 2 will be equal to instead of writing here, I'll write it here. 105 into 10 raised to power 6 into d by 2 will be equal to pi by 64 d raised to power 4 into 125. Now what I'll do, I have d and d. So what I'm gonna do, I'll keep this here as it is, as 105 into 10 raised to power 6 equals to pi by 64 d raised to power 4 divided by, I'll bring this to the denominator, d by 2 into 125. Now from here I can cancel this, and this will become pi by 64 d raised to power 3, and here from here I can cancel 2 into 64 will 232 will be 64. So from here I'm getting 105 into 10 raised to power 6 equals to pi by 32 d raised to power 3 into 125. And if I multiply pi by 32 into 125, I'll be getting 105 into 10 raised to power 6 equals to 12.27 d raised to power 3. This d raised to power 3 will remain as it is. Okay, so from here d raised to power 3 will be equal to 105 into 10 raised to power 6 divided by 12.27. so from here d raised to power 3. Now if you want to remove this power d raised to power 3, all you have to do is 3 root over of 105 into 10 raised to power 6 divided by 12.27. This will give you 204.54 mm. So this is the diameter of this circle. Okay, so if you draw a bending stress distribution diagram, it will be something like this. Okay, so here you have sigma t, and here you have sigma c, which is already given in the question. Okay, so I hope this numerical is clear.
Let's solve the third numerical. Find the diameter of circular section of a beam of 4 meter span to carry a load of 45 kilonewton at the center of the span if the permissible bending stress is 9 Newton per mm square. So let us see how we can solve this numerical also. Let's get going.
Now let us solve the third numerical. For this third numerical, we also again have to find the diameter of a circular section. So we have a circular section, and this beam carries a point load of 45 kilonewton at a center of the span, right? So it is a simply supported beam. And it carries a point load of 45 kilonewton at the center, and the span of this beam is given equal to 4 meter, and permissible bending stress is given equal to sigma is given equal to 9 Newton per mm square. Okay, now from here we need to find the diameter of circular section. Okay, so how do we find this? Again, by using a flexural formula, which is m by I equals to sigma by y. Again, we use a flexural formula to find the diameter. Now what will be maximum bending moment for this simply supported beam carrying a point load at its midspan? It will be equal to WL by 4. Okay, so how much is W? We have 45 kilonewton. Now if I convert it into Newton, it will be 10 raised to power 3 into length of the beam is 4 meter divided by 4. This cancel, I get 45 into 10 raised to power 3 Newton meter. Now I want to convert this meter to mm, so I'll get 45 into 10 raised to power 3 into 10 raised to power 3 Newton dot mm. Now 45 into 10 raised to power 3 plus 3 is 6 Newton dot mm. Okay, now if I want to find moment of inertia Ixx of this circular section, it will be pi by 64 d raised to power 4, right? We do not know d, so it will, let's keep it as it is. So y will also be d by 2. Now let us put it in this formula. So we will get m, we got 45 into 10 raised to power 6, I is pi by 64 d raised to power 4 equals to sigma. We got sigma is given in the question, which is 9 divided by y is d by 2. Again cross multiply it, you will get 45 into 10 raised to power 6 into d by 2 equals to pi by 64 d raised to power 4 into 9. Now bring this d and this d is distance, these are like term, let's bring it together and solve it. So it will be 45 into 10 raised to power 6 equal to pi by 64 d raised to power 4 divided by d by 2 into 9. D, this cancels, it will become d raised to power 3. 2 32 is 64. Now what do you get? 45 into 10 raised to power 6 equals to pi by 32 d raised to power 3 into 9. Okay, now if you solve this whole portion here, you will be getting 45 into 10 raised to power 6 equals to 0.88 d raised to power 3. Now from here d raised to power 3 will be equal to 45 into 10 raised to power 6 divided by 0.88. Now you want to remove this power root power 3, so it will be d equals to root over 3 45 into 10 raised to power 6 divided by 0.88. From here you will be getting diameter equal to 371 mm. So this is the diameter of this circular section. So I hope this numerical is also clear.
This is the fourth numerical for today. A cantilever beam of rectangular section supports UDL of 5 kN per meter. The span of the beam is 3 meter if the maximum bending stress is 100 Newton per mm square and the depth of the beam is 1.5 times the width. Determine the size of the beam. So let us get started with this numerical also.
Now let us solve the fourth numerical. Now in this numerical, a cantilever beam is given, right? A cantilever beam section supports UDL of 5 kN meter. The span of the beam is 3 meter. So it has a cantilever beam. The span of the beam is 3 meter. 3 meter, and it carries a UDL of 5 kN per meter. Okay, now we need a maximum bending stress is also given, which is sigma is given equal to 100 Newton per mm square. The depth of the beam D is given equal to 1.5 times the width times its width. So 1.5 into B. Determine the size of the beam. So we need to determine size of the beam. Okay, so we need to find D and as well as B. So let us get started. Again, for this, to find the size of the beam, we again use a flexural formula, which is m by I equals to sigma by y. From here only we will find the size of the beam. Now let us see how we can find. So for this cantilever beam carrying a UDL, maximum moment will be equal to WL square by 2. Okay, so how much is W? 5 kilonewton per meter into length L is 3 meter square divided by 2. So from here you get 22.5 kilonewton meter. Now if you want to convert this to Newton.mm, it will be equal to 22.5 into 10 raised to power 6 Newton.mm. Okay, now since this is a rectangular section, rectangular section के moment of inertia कैसे find करेंगे? I xx will be equal to bd cubed by 12, right? So how much is b? We do not know b, right? So let b be b only. और d कितना है? d is equals to 1.5 times b. So 1.5 times b cube divided by 12. So from here you get 0.28 b raised to power 4. इतना मिलेगा आपको. Now from here let's find y. Y is given equal to, it will be d by 2. तो d कितना है? d is 1.5 b divided by 2. This will come 0.75 b. Okay, now let us put in this equation. How much did we get m? M came equal to 22.5 into 10 raised to power 6 divided by I is 0.28 b raised to power 4 equals to sigma is 100 Newton per mm square and y is 0.75 b. Okay, now let's cross multiply it. 22.5 into 10 raised to power 6 into 0.75 b equals to 0.28 b raised to power 4 into 100. अगेन जैसे हमने लास्ट न्यूमेरिकल पे सॉल्व किया था, ये b और b को साथ पे लेके जाएंगे तो वी हैव 22.5 into 10 raised to power 6 equals to 0.28 b raised to power 4 divided by 0.75 b into 100. So this will get cancelled. It will b raised to power 3. Now 0.28 divided by 0.75 into 100 will give you 22.5 into 10 raised to power 6 equals to 37.33 b raised to power 3. Now यहाँ से अगर आपको b raised to power 3 फाइंड करना है तो b raised to power 3 will be equal to 22.5 into 10 raised to power 6 divided by 37.33. Now you want to remove this. When you remove, you will have a root here. It will be 3, right? तो अब आप इसको सॉल्व करते हैं तो you will get b will be coming equal to 84.47. So इसको हम approximately we can say it is 85 mm. So you got b equals to 85 mm. Now from here हम d find कर सकेंगे. d will be coming equal to 1.5 times b, which will be equal to 1.5 into 85 will give you 127.5 mm. So therefore size of the beam is equal to b into d. So this is the size of the beam. Okay, so I hope this numerical is clear.
This is the last numerical for today's session. A beam of rectangular section B into D in size is carrying sagging bending moment of 40 kilonewton meter about x-axis axis. Determine the dimensions of the section if maximum bending stress is not to exceed 105 Newton per mm square. Check the ratio D equals to 1.5 B. This is a different kind of question, so let us see how we can solve this numerical also. Let us get going.
Coming to the last numerical, here we have a rectangular beam. अब यहाँ पर beam का section is given as section is given as B into D, right? And what else is given? It is saying that it is carrying a sagging bending moment. So sagging bending moment kya hai? It is a positive bending moment. So this means that this is a simply supported beam. So we have a moment equal to 40 kilonewton meter, right? What else is given? Determine the dimension of the section if the maximum bending stress is not to exceed, अब bending stress दिया है, bending stress equals to 105 Newton per mm square. Now they have also asked us to take the ratio of D as 1.5 times B, right? Now if I want to convert this 40 kilonewton meter to Newton dot mm, so it will be 40 into 10 raised to power 6 Newton dot mm. Now we need to find the size of the beam again. जैसे हमने last numerical भी किया था वैसे ही हम करेंगे. तो we will have by flexure formula m by I equals to sigma by y, right? Now यहाँ से moment is given already. I, this is a rectangular beam, so I will be equal to BD cubed by 12, right? We do not know B, we do not know D, so let us put the value of B and D here. B is as it is B, D is 1.5 B cube divided by 12. So from here you will be getting equal to 0.28 B raised to power 4. You'll get this. And now y will be equal to D by 2. Sigma is given. Now let us put all its value. M is equals to 40 into 10 raised to power 6 divided by I is 0.28 B raised to power 4 equals to sigma is 105 Newton per mm square, and D is y is D by 2. Let's cross multiply. From here you get 40 into 10 raised to power 6 into D by 2 equals to 0.28 B raised to power 4 into 105. Now here I forgot to replace the value of D. The value of D here is 1.5 times B. So you get 0. Into 1.5 times B divided by 2, okay, equal to 0.28 B raised to power 4 into 105. Now here 1.5 times B will be equal to 40 into 10 raised to power 6 into 1.5 times B will be 0.75 B equals to 0.28 B raised to power 4 into 105. Now I send this together, so I get 40 into 10 raised to power 6 equals to 0.28 B raised to power 4 divided by 0.75 B into 105. This get cancelled and I have B cube. Now if you divide 0.28 divided by 0.75 into 105, you get 40 into 10 raised to power 6 equals to 39.19 B cube. Now from here B cube will be equal to 40 into 10 raised to power 6 divided by 39.19. Now you want to remove this B cube, remove here and you put this cube root over here. So from here you will get the value of B will be equal to 0.67 mm. Okay, now from here B is equals to 100.67 mm. D will be equal to 1.5 times B, So here you have 1.5 into 100.67. You will get this equal to 151.01. So approximately you can say 151 mm. So the dimension of this beam is equal to 100.67 mm into 151 mm. So this is your B into T. This is the section of this beam. So I hope this numerical is also clear. This is the last numerical for today's session. So I'll see you with more numerical in next session.